Alright guys, what's up? I'm back here with the last two of the hard problems. For 13, here we have a man runs at a speed of 4 meters per second to overtake a standing bus. When he's 6 meters behind the door, the bus moves forward and continues with a constant acceleration of 1.2 meters per second squared. How long does it take for the man to gain the door? Okay, this is a spicy question, and the reason it's spicy is because this is like the police siren question or the like tortoise and hare question. Basically, when you have two objects that are trying to catch each other, you have to say at the point that when the man catches the bus, his position is equal to the position of the bus. Right? Their positions will be equal to each other at the moment that he takes the door. He reaches the door. So, let's go ahead and check this out. We have variables. Remember, two objects means we're collecting variables for two sections. I'm going to look for man variables first, and then bus variables second. So we have delta x, we have vi, we have vf, we have a, we have t. For the bus, we have delta x, we have vi, we have vf, we have a, we have t. Okay, so their delta x's are going to be equal to each other when he catches it. That's fine. His vi, his initial speed is 4. Right? His vf, it doesn't say how fast he's moving when he catches the bus, so it doesn't matter. The acceleration, bus moves forward, continues with a constant acceleration of 1.2. Okay, so the acceleration of the bus is 1.2, and the man is running with a constant speed of 4 meters per second. So our acceleration is going to be 0 for him. And our time is what we're trying to solve this for. The time this takes is for both of them is the same. So the bus is moving forward. It starts out stopped, right, because it's standing. And our final velocity we don't care about here either. Okay, so we're trying to solve for t. We know all of this information about here. Sorry, let's go through this again. At the moment the man catches the bus, delta x and delta x are going to be equal. The initial velocity of the man is going to be 4. The initial velocity of the bus is going to be 0. The acceleration of our guy is 0 because he's moving at a constant speed. The bus, though, is going to accelerate at a rate of 1.2, and then our times are going to be equal to each other. Now, here's the deal. These delta x's are the same. However, the man on this side starts 6 meters away, so we have to add plus 6 to his side. Right? Because he's starting 6 meters away from the bus. They're not exactly equal. So, because he has to move an extra 6 meters, we have to add a 6 to this side. But then we can just solve this. Pretty easy. So, we don't have VF, we're going to use kinematic equation number 4. And what that means is, because kinematic equation number 4 is delta x equals vi times t plus 1/2 at squared, and their delta x's are equal to each other, we can just set this part of the equation equal to each other for the man in the bus. This is the same as the F0 problem or the siren cop problem, right? So that's going to be 6, because we have to start with 6, plus his initial velocity is 4 times t, plus 1/2 his acceleration is 0 times t squared, equals the bus is going to be vi, which is 0 times t, plus 1/2 its acceleration is 1.2 times t squared. So let's go ahead and take a look at this. 0 times t times 1/2, boop. 0 times t, boop. We get 6 plus 4t equals 1/2 times 1.2 is 0.6 t squared. Man, this is going to be another quadratic, isn't it? Ah, jeez. Yeah, it's my fault. I don't know why I went so ham in the paint with this. I wrote this question before I did it as a practice. I guess that's on me. I didn't realize it was going to involve another quadratic. But you see, like I said earlier, we have these t's and we don't really have a good way of getting rid of them. So we can subtract 0.6 t squared from both sides. we get 6 plus 4t minus 0.6 t squared equals 0. And then I'm just going to ask my quadratic formula calculator what that is. And you guys can do the same when you reach a point like this. I don't really think it's that big of a deal. We get negative 0.6 t squared. Okay. So our t we end up getting from this expression is t equals 7.9 seconds. And there we go. So, yeah, that's the answer for this one. So, hope you guys were good for that. Sorry. All right, last question. We want to look at this graph, find the displacement and acceleration of each segment. We have segment A, segment B, segment C, segment D, and segment E. This is something we talked about a little bit briefly. That's why I made this one a hard question. It's actually not that hard, but it is something that we only talked about very briefly, and it's something that ultimately I'm not going to be super worried about on the test or anything like that. But this is an important part of physics. So normally we graph position versus time. This is a velocity versus time graph. So remember, a graph shows you the change in stuff. The slope of a graph shows you the change in this relative to the change in this. Rise over run, right? So here, our rise is velocity, and our run is time. Delta V over T, what's that? That's acceleration. So the slope of this is going to be acceleration. Now the displacement. The displacement is our delta X. And remember, delta V, right, change in velocity is a change in displacement over time. So what we can do here is so what we can do here is we can find the displacement by doing the opposite of taking the slope, right? If we take the slope, we get the acceleration. If we take the displacement, or if we want to find the displacement, we have to do the opposite of taking the slope. And the opposite of taking the slope in a graph is finding the area under the curve. So for section A, for instance, we could find its slope really easily by doing rise over run. We could find its displacement by doing the area under the curve. So let's go ahead and try this out. So for A, its acceleration is going to be our change in velocity, so Vf minus Vi over T. So that's going to be, we go from 0 to 30, it's going to be 30 minus 0 over in 5 seconds. So 30 minus 0 is 30 divided by 5 is 6 meters per second squared. So that's our acceleration. And then our displacement is going to be geometry. So here, this is a triangle, right? We want to find the area under the curve. This is a triangle. So the formula for area of a triangle is 1/2 base times height. We can do that. So that's 5 seconds is our base. That's 5. Our height is going to be 30. So that's 1/2, 5 times 30. Oh, geez, my thing's cut off. Sorry. 1/2, 5 times 30, which is 15 times 5, which is going to be 75. So delta X is going to be 75 meters. So that's how we do it for A. Let's look at B now. So B, we go from 30 to 30 over the course of another 5 seconds. So A is 30 minus 30 over 5. That's equal to 0 meters per second squared. And then our delta X is this. That looks like a rectangle to me. So formula for area of a rectangle is going to be width times height. Width here is 5. Our height here is 30. So that's just going to be 5 times 30, which is 150 meters. Okay, now C. For C here, we're looking at this section. So we're going to go from 30 to 20. So that's A, acceleration is going to be final minus initial, 20 minus 30. Right, the second minus the first. Over, it takes place over 5 seconds. That's going to be negative 10 over 5, which is negative 2 meters per second squared. And then our delta X here is going to be 5 seconds. This looks like a trapezoid to, sorry. This looks like a trapezoid to me. So a trapezoid is 1/2 base 1 plus base 2 times height rather. So here is 30, here's 20 is B1 and B2. So that's 1/2 30 plus 20 times the height, which is going to be 5. So that's half of 50 times 5 is 25. 25 times 5 is 125 meters. Okay. By the way, just so that you guys know, there is not a question that's like this on the test with finding the area under the curve. I could put one on there. You guys can probably handle it, but I just didn't put one on. So don't worry about it. If this is like confusing to you or you're having a hard time following, we didn't really talk about this in class very much, but I wanted to put this on here just so that you guys could remember. Okay, so let's look at D next. D, we go up here, there's D, there's 5 here, this height is going to be 20, that looks like a rectangle to me, and then finding our slope, we go from 20 to 20 again. So notice our acceleration is going to be 20 minus 20 over 5 seconds, and that's 0 over 5, which is 0 meters per second squared. And then our rectangle is 5 by 20, which is 100 meters. Now, you can also tell, by the way, that this is a zero slope because it's a flat line. All right, and then lastly, we go from here to here. So for part E, this looks to me like a change of, we go from 20 to 0. So that's 0 minus 20 over, it takes another 5 seconds. That's negative 20 over 5, which is negative 4 meters per second squared. And then our delta x is going to be, this is a triangle, so delta x equals 1/2 base times height again, because it's a triangle. So we end up with delta x equals 1/2. Base is going to be 5. Height is going to be 20. Half of 20 is 10. 10 times 5 is 50. So that is how we do this section. Not that bad, but it's a little obtuse if you don't remember it from when we talked about it in class. So that is going to be this homework. That'll be it for this one. It's a little bit tricky. There were a couple of questions I went a little bit overboard with, but that's okay. You guys are smart. I think you'll figure it out. And with the help of my videos, of course you can figure it out. Hopefully these are helpful for you guys. I hope that they aid you in doing the homework. And thanks for watching. I'll see you next time.